Hi, my board is frozen. I'm secretly doing the answer over here so they can check their work in a couple of minutes, okay? All right. What you guys do? Looking good. We rejected the -2 because x must be greater than 2. We fully condensed the left-hand side before we exponentially base 2 on both sides. Yeah. All right, cool. Let's do some trickier problems. I'll check homework once everyone gets here. Otherwise. See, I feel like we could probably like figure these two out on our own. The ones I wanted to do with you were 4. Okay. So, let's read question 4. Question 4 says, let f of x equal, by the way, we're not learning anything new today. Yay! We're just doing harder versions of log problems that you might see on the IB exam, okay? We just did 3 as a warm-up. You can watch the video if you want. Now we're on 4, okay? It says, let f of x equal k times log base 2 of x. Given that, so now we're talking about in the inverse, right? We have the inverse of 1 is equal to 8. Find the value of k. So on the original, right, this would be a y, and this guy would be an x, right? So the point 8, 1, hey, lies on f of x. So they gave us like a little clue as to the inverse, right? So if we have the original and we're trying to solve for k, why don't we go ahead and set the whole thing equal to 1. That's our y output of 1. And then we have k times log base 2 of, and then x is 8. All right? So now we have 1 is equal to k times log base 2 of 2 to the 3rd. The 3 drops down, this disappears, and I have 1 equals 3k. Divide by 3. K is 1/3. Whoop, whoop. Now, we want to find the inverse of 2/3. I don't know about you guys, but I don't really feel like finding the inverse. Do you? When we could just kind of use the same structure that we did before to save time. We should just take this guy, now that we have k, and set it equal to 2/3. Wouldn't that be a little faster? It would, right? Do you see how this guy is a y on f of x? And that's kind of the line of reasoning that we're going with here. Yeah. So now I've got 2/3 is equal, and I'm putting in the 1/3 k that I just found, log base 2 of x. All right, so the easiest way is to probably just multiply both sides by 3. That will clear this guy, and it'll clear the denominator of 3 here. So I now have 2 is equal to log base 2 of x. And then I'm going to get rid of the logarithm by basing 2 on both sides. So I've got base of 2, base of 2. I now have 4 equals, this guy disappears, x, and my answer is, on the inverse function, the inverse of 2/3 is 4. Okay, hello, how's it going?
That's good.
That's good, that's good, that's good. Only 2 sets between us and Thanksgiving break. We got this, guys. Was that it? That was it. All right, let's go to 5. 5. Again, tricky log question, but that's okay. It says, write the expression 4 times the ln of 2 minus the ln of 8 in the form of ln of k. So in the form of ln of k just means as 1 log. So are we going to be condensing or expanding? Condensing, right? And what base do you guys think we're going to be condensing to, kind of? We've got ln, and then in the argument there we've got a 2. So if we could rewrite everything as ln2, wouldn't that be pretty easy? It'd be pretty good, right? So let's move this exponent up to be in the argument of ln of 2. And then I've got the ln of, how can we rewrite the ln of 8 as something with a base of 2? And then now, if I have like bases and I am subtracting, I can combine the arguments with division. So I now have the ln of 2 to the 4th divided by 2 to the 3rd. And I'm not going to bother doing the actual math because I know when I divide like exponents, I get to subtract. So I'm just left with the ln of, woo, hence or otherwise, meaning using the stuff that you just found up top, solve for ln of 2 minus the ln of 8. Hang on. Where is this also on your page? Right above it. And what's the easier version to work with that you just found that's equivalent? ln of 2, right? So that's what they mean by hence or otherwise, meaning look for the structure up top. And then this becomes a much easier problem, okay? So I've got the ln of 2 equals. I would love to base E both sides, but I can't as is because I have this little thing right here. So what I have to do is take that -1 coefficient and make him an exponent. And then just kind of careful, like this whole thing is to the negative first. So if I were to rewrite that as a fraction, it would be 1 over 2x, all right? And now I can E both sides, whoop, whoop. And I have 2 equals 1 over 2x. How do you solve something like this? Cross multiply. 1 equals 4x divided by 4. X is 1/4. Okay. You feeling okay? We ready for anything? Yes, we are. Yes! Who's going the farthest away this break? Who thinks they're going somewhere pretty far? Is anyone leaving Rochester? No? Where are you going?
Tarrytown, New York City.
Oh, okay. I'm from Long Island, so I've probably driven through it on my way. What is it near? What?
Tarrytown.
No, but like what is like a neighboring town?
It's near like Yonkers, kind of.
Yeah, yeah.
It's not in like. It's not on the island, but
Yeah, it's up by like Westchester County, kind of. Yeah. Who lives there?
my cousins.
Cool. Are you guys close? Oh my gosh, I know, I'm so excited to see my cousins. We're going to Rhode Island to my sister's house. I can't wait. Are you all going to just Rochester? Who's hosting this year? All right. And then everybody else just Rochester area? Yeah. Still fun. All right, cool. Read this and just like take a second to process. Just, you know, it's going to be not so great when we have to take a second to process. So go ahead and read it. Process. Do you have your packet? Do you want some paper? He's back, baby. We got him. We got him. All right. If I have to solve a system of equations, and one of them has a base of 5, and one of them has a base of 7. Let's start by condensing the first one and see where we land, okay? Then we'll do it on the second one, and we'll see where we land, okay? All right, so what do we know about logs? They are snobs. So if I have a 1 and I got to kind of figure out how to condense that with other stuff, I'm going to rewrite him with the same base as that first thing. So I've got 1 plus 2 log base 5 of x equals log base 5 of 7y. Okay. Oh, excuse me. What base should I change, or what should I change this 1 into? What do you guys think? Log base 5 of 5 plus. And then I'm going to take this 2 and bring him up to be an exponent, because I know I'm going to be consolidating these arguments here, right? So I've got log base 5 of x squared equals log base 5 of 7y. Okay. I'm now going to combine the arguments of log base 5 of 5 plus log base 5 of x squared. The operation in between them is plus, so I'm going to multiply the arguments, and I've got 5x squared equals log base 5 of 7y. Ooh, when we have a log base 5 on both sides, if I raise both sides to an exponential base of 5, everything comes out. Isn't that awesome? So now I'm left with 5x squared equals 7y. You are, but I see a 7 and a y kind of next to each other, like here. So I'm just going to kind of like consolidate this guy on the right and see if I can maybe save myself some time. I'll show you what I mean. So I'm like, okay, I see a 7 near there. I'd rather not use change base formula if I don't have to, but like it's always available to me, and we love him no matter what. I'm changing the 1 to a log base 7 of 7 with the hopes of combining the arguments on the right. So I now have log base 7 of 6x minus 1 equals log base 7, and then in here I've got a what? Log base 7 of 7 plus log base 7 of y becomes what? Log base 7 of 7y. So now when I raise both sides to a base of 7, what do I get? Hey, don't I have 2 equivalent expressions of 7y? Can't I just set them equal as is now, right? Just reduce, then I don't have to work with fractions, reduce my workload just a little bit. So I'm going to solve for x by setting these 2 equal. And then I think it gets very complicated because I believe we get 2 answers. So hold on. I now have 5x squared equals 6x minus 1 minus 6x minus 6x. 5x squared minus 6x equals negative 1 plus 1 plus 1. 5x squared minus 6x plus 1 equals 0. I'm now looking for the factors of a times c, or 5 times 1, that add up to negative 6. That's, of course, going to be negative 5 and negative 1. So I split the b term into negative 5x minus 1x. I pull out my GCFs. I now have 5x minus 1 times x minus 1. I now have x equals 1/5, x equals 1. Since I have 2 different x values, and I'm trying to find the y's because I have to find the points where these 2 things cross, right? It looks like there's 2 points of intersection. Let's just make sure both of these fit in the argument of the log. Are any of these going to make it negative? No. Nope, we're good. Okay, so let's go ahead and try to find what y is when we plug in each one of these, okay? So let's be smart about our plugins. If I have x equals 1/5, which one would you prefer to plug that into? The one with log base 5. Good job, right? So actually I don't have nearly enough room. I'm going to scooch this over. Hope you're not working in pen. Okay. So I'm going to plug this guy into the one with log base 5. 6x minus 1 equals 7y.
Like, why would you have to?
Oh, yeah. You can if you want, sure. That was a really funky looking Y. Oh, I hate this eraser. Hold on. We'll see you there in an hour. Hold on. Come on. There we go. Okay, so the first point of intersection is going to be 1, 5/7. Next, which is the one that's going to make the 5 go away? This one. Oh wait, no, I don't like this way. I was trying to solve time and save time, and that's not going to work. Let's do 5/25 equals 7y. Yeah, and then we'll reduce it right here. That works. Okay, so I have 1/5 equals 7y over 1. 35y equals 1. Y equals 1 over 35. So if I put it all together, all right. Okay. That's not so bad once you got on the bus, right? Okay. This class is a little ahead of the other class. Let's do 7. Solve the equation 14 to the 6x equals 64 times x, 64 to the x plus 3, 4x. And now we want to express our answer in terms of ln of 2 and ln of 7. This is going to help us guide when we do our solving, right? Okay, so I've got 14 to the 6x equals 64 to the x plus 3. What can I do to drop those exponents down in the front? What can I do on both sides? I'm going to, well, what log do you think I should use to drop those down? Probably ln, because that's how I want my answers to finally be written, right? So if I ln both sides, this can now drop down as a coefficient, and so can this. So now I've gotten my x's out of the denominator, or out of the exponent. Thank goodness. Okay. So then now I'm going to want to do a couple of things, right? Let's work left to right and just organize ourselves here. If I'm trying to get to an ln of 2 and an ln of 7, what do you think you should do with that 14 argument there? Right, this can be expressed, why is this so much thicker? Hang on. The disgust in my voice. Okay, here we have 6x times the ln of 7 times 2, right? Then we have x plus 3 times the ln of 64. All right, so then now I'm going to break this up as there's a 6x out front. Be careful, right? And then inside the parentheses, I have the ln of 7 plus the ln of 2 equals. And then logs are weird because usually logs are just a decimal. They're just like a number, right? Usually we would write that in front of the x, but I feel like it's easier to like keep track of the terms if you just do this. Are we okay with this? Yeah. Okay. So now I'm going to distribute over here. I've got 6x ln of 7 plus 6x ln of 2. And then over here, what are the arguments of ln that I'm trying to get to? 2 and 7, right? So how do you think I should rewrite these guys over on the right here? Got the ln of 64, so 2 to the 6th. And then I've got the ln of 64. Oh, that's the same thing. So we've got 3 times the ln of 2 to the 6th. Perfect. I'm going to drop those exponents down. I'm going kind of fast. Are you guys okay? Are you guys okay? Okay. So I got 6x ln of 7 plus 6x ln of 2 equals 6x ln of 2 plus 18 ln of 2. Does anyone see our next move? Is it surfacing in your brain? Yeah, they're on both sides, right? So I'm going to if I subtract it on this side, he's just going to end up canceling on the other side. That's awesome for us. And then I've got 6x ln of 7 is equal to 18 ln of 2. Okay. Couldn't I, just to like make things go a little faster, right? Couldn't I take this piece here and rewrite it as, and rewrite it as 6 ln of 7 times x? I could, right? I'm just rearranging the order. Multiplication is commutative. Like, sure, put it wherever it needs to go. So if I have that, what is the coefficient that I get to just divide both sides by now? Yeah, 6 ln of 7.
I'm so good.
He is so good. Yeah, that's great.
Wait, why would you divide by 6 ln of 7 over the ln of 2?
What do you mean?
It's like, you divide by 6 ln of 7, but like on the other side it's 18 ln of 2, and then you divide by 6 ln of 7 when it does. Oh wait, it's a number.
Did you get it?
No, that's okay.
No? Wait, what do you mean? So like this, we rewrote, so this could just be the coefficient of x.
Yeah.
Then I can just divide both sides by this.
Okay.
And then now I could just reduce this, right?
Yeah.
So that becomes just a 3 up top, and then now I have the ln of 2 over the ln of 7. Are you good now?
Yeah.
Woo! All right. Is our answer the way they want it? Express your answer in terms of ln of 2 and ln of 7. That's all we can do. Boop. How could you check this on a graph? Do you guys know? In case it was a test and you wanted to see if you were right? Let's go to our calculator. Please be already awake and available. Please, please, please. Sort of. Okay. So I'd go to the original problem, and I'm just trying to find where the left-hand side equals the right-hand side. So I'm going to graph each piece and see where they cross, right? I've got 14 to the 6x. And then, look at that, he's like a straight up. And then I got 64 to the x plus 3. Okay, I'm going to need some more of these. I'm going to need way more of those. Or, let's see what's going on here. Analyze graph, intersection. There is one. Oh, good. It took us right up to it. Perfect. So it's intersecting at 1.068622. So you'll know you're right when you... What are you going to do? I just graphed it. I just found where they cross. I'm hearing like, check it, graph it. I feel like you guys know what to do, but like, what would you do? You just type in the 3 ln of 2 over the ln of 7 and then get a decimal and see if it's the same as where they crossed, right? Yeah. So I've got this thing. Oops. .068. 1.068. Yay! So do you know how to check this if this was like a test question or something? Right? Yeah. Perfect. Okay, so your homework is like a little funky. So I wanted you guys to do pages, it's on the board, 30 to 31, and then there's a video. Oh no, that's what we just did. I wanted you to do pages 27 to 29, and then there's a video. And then there's also an optional practice up there that you could grab. If you did the optional practice from the other day and you want to turn it in, I'll give you extra credit for it. That's fine. I'll do the same thing for this guy too, okay? It's just like additional practice. There are questions that are like the questions that are going to show up on the test, or at least the same equal rigor, okay? So what you're going to do right now is just see if you can finish 1 and 2 right here, and then you can start your homework. Sounds good? I'm gonna come around and check your homework, okay?
So we're not doing pages 32.
No, because like the questions that you just did are way harder, so like what's the point? Like if you could do those, you could do those, you know? Right? Doesn't that make sense? I don't want to just give you work to give you work. Huh? You're going to do 1 and 2 right now. They're on page 29. And then you could start your homework if you want. Is 1 really hard?
Yeah.
Is it 1/3?
Or what?
You said
Yeah. Do you guys want to do? We can do 1 together. I'm cool with that.
Wait, where is this? I'm so confused.
It's on page 29.
29?
Yeah.
Oh, I was going at 27.
Oh, there you go. Hey. Okay. So I got the first 3 terms of a geometric sequence R. The ln of x to the 9th, the ln of x to the 3rd, the ln of x, for x is greater than 0. Find the common ratio. As is in this current structure, is it obvious what we are multiplying by to get to the next term?
Yeah.
I don't know. I'd probably drop the exponents down just to see what the multiplier out front would end up being, right? I'm going to rewrite this guy as 9 ln of x, 3 ln of x, ln of x, right? And then, now I'm like, okay, if I wanted to find the ratio, it's always second over first. And I'm like, it's 1/3. So R is 1/3. That's not the tricky part. The tricky part is B, but it's also like not tricky if you just trust your gut, okay? So let's trust our gut and look at B. We are solving a geometric series. I see a little sigma notation, so I know I'm adding all the terms together, right? I'm starting when K is 1, and I'm going until forever, right? So I've got an infinite geometric series, right? If only I could pull out the structure of this thing's terms, then I could find the unknown x that will get me to a final sum of 27. Who's getting a LaCroix of a feeling of what we have to do? Just a gentle, careless whisper right in your ear, just making it as creepy as possible. No one's raising their hand because they're horrified. Okay, let's look and see if we can find the first term. Let's just find the first term. It's giving this. Can we all agree? Yeah. All right, let's find the first term. Okay, it says the first term happens when I plug a 1 in for K. So I got u sub 1 is equal to 3 squared ln of x, which is 9 ln of x. Hey now. Where do you see a 9 ln of x as the first term in a geometric sequence anywhere else on your page? Like right up top in A, right? Oh man, okay, this is actually such an easy question. Yes. So I have u sub 1 is what? 9 ln of x. And then what's going to go down below? 1 minus 1/3. Where'd you find that 1/3 though? It's the R we just found, right? Okay. And then this whole sum is supposed to be equal to what?
27.
Yes. I only have one unknown. I can totally do this. I can do this. So now I have 1 minus 1/3 is going to give me what? Yeah, so I've got 9 ln of x divided by 2/3. Okay. So if I were to cross multiply, right? Or I could do 9, there's a few things I could do, whatever you're most comfortable with, but like 9 ln of x divided by 2/3 will give me 9 ln of x times 3 over 2, right? So now I have 9 times 3 is 27 ln of x over 2, right? Was that too fast? You guys good? We okay? Do you want to just multiply both sides by 2/3?
Yeah.
Okay. Okay, sure. We can do that too. That's fine.
Can you cross multiply and then get 18 equals 9 ln of x?
You sure could, which is exactly what you would have gotten if you did this, or if you cross multiplied, or if you did it my way. Do you see how it's just like a choose your own adventure? Just get rid of the fractions, however you want. I'm gonna do it the way that I was gonna do it though, because then I don't have to have big numbers. That's all. Just Just avoiding those big numbers. So now I've got 27 is equal to 27 ln of x over 2. So you see how if you cross multiply, you could be like, oh, what's 27 times 2? And then I have to divide it by 3. And then, like, if you see the number sense, you're good. But if not, you know. So now I'm going to multiply both sides by 2 to get rid of that fraction. Yeah? Oh, we have to do it anyway. So what am I talking about? So now I got 54 is equal to 27 ln of x. And then now what? I feel like kids get to this spot and then they're like, I've got the ln of x equals 2. Yeah.
You convert it into a power?
Yeah.
ln of x is log e of x. So you put it, I think e squared equals x.
That was beautiful. Brennan is a poet. And we exponentially base e both sides. This cancels because ln of x, or ln of ln is log base e. This cancels. X is e squared. Dang! All right, now you just have to do 2.
So our homework
And then you're
is
good.
29.
No, it's whatever's written on the board. What is it? 30 to 30. No, that's classwork. Can't read. 27 to 29. It's just like graphing and I just want you to have like a little experience with graphing logarithm graphs. It's easy. It's like you can do it independently and you're like, once you do it, you're like, I got
I
it.
was looking at number 1 and I was confused. I thought you were talking about number 1 on the first page. And I was confused.
No, you're good. Of this one? Here, come here. I'm coming. I'm coming over. Which one?
I don't even know which one was talking about. Are you talking about one of these graphs, or am I just?
So this happens when a, like the base, is greater than 1. So if it's like 2 to the x, log base 2, then this is when the base is a fraction. The color pretty much, that's like the one where a is greater than 1, this is the one where a is a fraction.
Where's that?
Like do this whole part and look at these, and then you're like, the function f of x is a log base, so this is like a new one talking about things.
It's not even, it's not one of those. That's why.
No. Okay, I'm pausing this. Check your homeworks.